Hi guys, welcome back to our digital VLSI channel. Hope you are all good. Today I would like to say about swapping two variables. Here I am writing swapping two variables. Like we will discuss about how to swap two variables using Verilog. You will be seeing how to swap two variables in C or C++ or Python or any software language. Now we will see how to write it in Verilog. First, we will use the common method. As you all know, in C or C++, to swap any two variables, you use a temporary variable, right? So, first we will see by using temporary variable, and then we will discuss about it in another way. So, first, it's first, every Verilog module start with module and end with the end module. So module some name I have written TB, or you can write like swapping two numbers. I'm declaring two variables, that is a comma b, and it is a traditional method like we use temporary variable to swap any two variables. So I'm writing temporary variable here, and then these are all basic stuff, so that's why I'm not explaining why we need to write this, why we should not write this, because if you see my tutorials, then you may easily understand. So I will suggest, if you are seeing this video for the first time, I will suggest you to go back to all of my tutorials once, because I explain from basic to advanced in a detailed way. So please try to explore my tutorials and then come back to see this video. So initial begin. Suppose I'm trying to give a and b we declared as integers, so I'm trying to give a equal to 4 and b equal to 6. And then I want to print first these numbers, so we use $display. A comma b. And then traditional method, we use temporary variable. That means using temp. Using temp, we will do swapping. Without using temp also, we will do swapping. Okay. Temp equal to a. Why I am using temp here means, suppose for example, what I need, a equal to 4, b equal to 6. In the output, in the output, I need to obtain a equal to 6, b equal to 4. So this is what I need to get, right? So that's why I'm using temporary variable, because if I use temporary variable here, then a value, that 4, goes into temporary variable, and then a equal to b value, here b value goes to temporary variable, sorry, a, b value goes to a. And also I am using blocking statements here. If you keep equal to, then it is blocking statement, so that output, I mean the simulation, if the simulation comes here, definitely it will execute this statement, and then only it will go to the next statement. Okay, after assigning temp equal to 4, after that only the simulator moves to this line number 15. Okay, That is the use of blocking assignment here. That is equal to, and b equal to temp. So I mean, why I have written these three statements here. Temp equal to a means temp equal to 4, a equal to b 6 is assigned to a, so that one we got, that is a as 6, and then the temp variable is assigned to b, so that we got b also. So that's how it is written. You may ask, like, why can't we write a equal to b and then b equal to a, right? One second. Why can't we write a equal to b and then b equal to a? I will explain this in a minute after executing this. Swapping using temp variable. A equal to percentage d comma b equal to percentage d a comma b end, and then end module. Okay, let us try to execute this first and then we will see about that case. Synopsis VCS and then run. What it is showing here, what we have given a equal to 4, b equal to 6. What we obtained a equal to 6, b equal to 4. Perfectly working, right? So now let us try to give this. We will comment this. How to use multiple comments by using slash and star. And at the end also star and slash. This we will remove and let us see what will happen. See, a equal to 4, b equal to 6 is a given thing, and what we need to get is a equal to 6 and b equal to 4. But what we obtained is a equal to 6 and b equal to 6. So it is not following a swapping manner. Why it's not following means, as I said before, it is blocking assignment means definitely here a should be assigned to 6, and then only it needs to go to this number 19th line. So after when it goes to this number 19th line, what is a value? 6. So that's why here b also print as 6. So that is the reason we use temporary variable. Okay, so I'm deleting it, and then this is the solution. Yes. And another method also is there, without using temporary variable, to get how to get this swapping method. I will say, let us copy this first and then paste it here. Yes, instead of using temporary variable, how to achieve swapping method is our goal, without using temp, right? Yes, what we use is non-blocking assignment. First let me write code and then I will explain each line why we need to use this non-blocking assignment. Before we used blocking assignment, it didn't work, so we have to use the temporary variable. Then what's the solution to obtain swapping method without using temporary variable is we need to write blocking non-blocking assignment. Non-blocking assignment here is less than equal to non-blocking assignment. Okay. Okay, let me explain. In Verilog, there is stratified event queue. That means timing events. At that particular time, it follows some rule. Okay, I will try to explain it. First, in this stratified event queue, there are these stages are present at every time slot. That means, let us suppose this is at t equal to 0. Okay, at t equal to 0, we every line goes through these statements. um, First, a equal to 4. Here initial begin started at what time? Time equal to 0. This is at time equal to 0. A equal to 4. Here assigns in this first block active events. What are the statements that execute? Blocking assignments, dollar displays, RHS evaluation of non-blocking assignments, and assign statements. So a equal to 4 is what? It's a blocking statement, so it executes in active event. So in here a equal to 4. In the same way, b equal to 6 also occurs here. That means the value 6 is assigned to b in this active event stage. And also, dollar display should occur at active events time. That block. Time slot is same for everything. Within time slot also they follow these stages. So a equal to 4, b equal to 6 also execute at this active event block, and then the simulator comes to a less than b. Now, it's a non-blocking assignment. You need to keep it in mind. Less than or equal to is a non-blocking assignment. So, what it is mentioned here, RHS evaluation of non-blocking assignments. That means a less than or equal to b. Every time this RHS, that means b, it should get b value, right? From where it will get? From this active event. In this active event, what is the value of b? Is 6. So b, now what it will become is a less than or equal to 6. At what stage? Active event stage. But b will be assigned to 6, but it won't assign immediately to a. Okay, it just schedule this a equal to 6 to update LHS of NBA. So it just schedule this a value as 6 to here. So let me write here a value as 6. Okay, here in this non-blocking assign update LHS of NBA. Similarly, b less than or equal to a here a comes from active event. What is that? A value 4. B less than or equal to 4, but it schedules b equal to 4 in which stage? In this stage only. So b equal to 4. Okay, now it's better to here we should not write dollar display. Dollar monitor is good because dollar display again it gives this one only a equal to 4 b equal to 6 because at one particular time slot here what happens is a less than or equal to b. Simulator blindly sees b value as blindly assigns b value as 6, but it won't assign a value, it just schedule here, but simulator is still here only. Okay. In the same way, b less than or equal to a value is updated to 4, but it doesn't assign to b immediately, but it schedules to here. That is non-blocking assign update block. Afterwards, the simulator comes to here. It is dollar display. That means in active event it should occur. Definitely it should occur. What is the a value and b value? The same as it is a value as 4, b value as 6. Because these two didn't update yet. The simulator doesn't comes here. Okay. So that's why we should not use dollar display here. We need to use dollar monitor. Okay. I mean um after coming here, after coming to dollar monitor, the simulator sees whether is there any statements to occur in active events. If no, the simulator goes to next block. Is there any statements that is has zero delay assignments? In this, no. So the simulator goes to non-blocking assignment. Now here it updates a value as 6, b value as 4. Now a is 6, b is 4, and then dollar monitor is present. So monitor should occur at this stage. When it comes to this stage, when it comes to this stage, a is assigned as 6, b is assigned as 4. That means swapping done perfectly. So this is about stratified event queue, that is Verilog event queue model, which is very important. Here I explained it in a brief manner. I will tell you in detailed way in after some of the videos. And so, okay, let us try to execute this first. See, oh, okay, one second. Here swapping without using temp variable. Again, you will get a confusion. So that's why. See now, a equal to 4, b equal to 6 is our input. After swapping, what we got a equal to 6, b equal to 4. So this is how we use or we obtain swapping in Verilog by using non-blocking assignments without using any temporary variable. Thank you guys. If you really like this video, please like, share and subscribe to our digital VLSI channel. Thank you. Bye.